All right. Well, AP Stats, kind of a bittersweet end because it's always kind of fun being together that last time that we have to learn something new for the year. But let's kind of enjoy it still, being that this is the last new stuff that you've got to learn for AP Stats this year, and we've learned a lot. Uh, so that being said, we're going to kind of put everything together, wrap up regression, wrap up correlation, kind of tie a bow on everything here, and start getting ready for that AP exam. So first question for this section: does it matter which variable is x and which one's y? The answer is kind of yes and no. Um, if you think about it in terms of the equation, the answer is a definite yes. When you're looking at kind of making your equation, it's very important what you make x and what you make y. As for the correlation, and I think we've already talked about this, as far as with r, the answer is actually no. You can switch x and y up; it'll actually be the exact same r value, same exact decimal, same exact sign. So if it was an r positive r value to begin with, it'll stay positive. If it was negative to begin with, it'll stay negative. Which is kind of interesting. I mean, if you think about switching your data around, you'd think that it might change a little bit, and actually it doesn't. So the next one: which of the following has the highest correlation? So you've got four different graphs, four very different looking graphs. So which one do you think has the highest correlation? I'm just curious to let you think about that for a little while. If we were in class, I'd take a poll to see which ones you thought were probably the highest. Usually it comes down to either the first one here, where you're thinking about a least squares regression line and thinking, oh, that's pretty good. The next one, you're probably thinking, it looks like it should be probably something else. The third one usually gets quite a bit of votes when I ask the class about this in person. Even though you've definitely got that one outlier, you're still thinking probably pretty close data. And then the last one usually doesn't get very many votes, kind of like the second one doesn't. But here's actually the thing, and maybe you were thinking this in the first place because you probably thought, well, this is probably a trick question, and I suppose it kind of is, but it's actually that they all have the exact same R value. In fact, that R value is relatively strong, 0.816. What I thought was actually even more interesting, and these are a special set of four graphs. I can't off the top of my head remember what they are. If you do just quick Google search for correlation graphs or something along those lines, you can figure out the guy who discovered these. But what's actually really interesting is they actually all have the exact same line of best fit. Is that the line of best fit for each of them is 3 plus 0.5x, which I think that to me is almost more surprising than the fact that the R value is the exact same. So just to kind of let you know, when you're looking at something for correlation, don't just kind of look at the graph. Make sure you're looking at the R value that your calculator gives to you, because you might be surprised by the R value that it comes up with. So, but how do outliers affect the correlation, your least squares regression line, the standard deviation, the residuals, and are all outliers influential? Let's just kind of take this piece by piece. So the first thing it asks about is the correlation. So how do outliers affect the correlation? They make it weaker. How do they affect our least squares regression line? Well, the answer to that, it depends. Do they influence it? Yes, they definitely influence it quite a bit. But it depends on whether the outliers are above the rest of the data or below the rest of the data, as to whether or not the slope gets changed, that the y-intercept gets changed, and so on. Next thing, S, your standard deviation of the residuals. That's going to become much larger. And that's just because obviously you're going to have a couple of residuals that are much higher compared to the rest. Finally, are all outliers influential? The answer to that is yes. So all outliers are influential, no matter how far away they are. They definitely influence the rest of your data. So what we're going to talk about, these last two graphs, are just kind of how do those outliers influence the data, what would be the effect if they were to be removed from the data, pretty simple concepts, just things that didn't really fit into other sections of the notes for this unit that we still need to talk about. So here's a scatter plot that shows the cost in dollars and the battery life in hours for a sample of netbooks or small laptop computers, so think Chromebooks, something along those lines. What effect do the two netbooks that cost $500, so these two right here, have on the equation of the least squares regression line, the correlation, your standard deviation, and the other residuals and R squared? So let's just think about, first of all, our line of best fit, our least squares regression line. Take out those 2 points and imagine a new line of best fit. I would imagine something that looks maybe something kind of like this. So I would say it actually influences a couple things. For the first thing, our slope, it changes it from a negative slope to a positive slope. It also is a much steeper slope, so it increases much more rapidly. As for your y-intercept, take a look at where it crosses the y-axis, and it's going to actually have a much lower y-intercept now. Okay, next thing, correlation. Well, I think it'd be safe to say the correlation is now going to be positive. It's also going to be much stronger, so it's going to be closer to +1. Which I guess that actually kind of leads nicely. I'll kind of skip around a little bit. Remember, correlation is your R, so as far as R squared goes, that's also going to get larger. As for S, which is the standard deviation of the residuals, obviously standard deviation is going to decrease, and so the residuals is also going to decrease as well. So that's actually going to get smaller. Okay, so continuing, one more graph, last graph. Crazy. So I've got a scatter plot for us. It compares the relationship between the number of fouls and the number of points scored for NBA players in the 2010 to 2011 season. The first thing just asks us to describe the association. So when you're looking at the association, you're just looking at the scatter plot. We're not going to talk line of best fit, none of that sort of stuff. So first thing that I would maybe talk about would be the direction. I think we could all agree that this definitely has a positive direction. As the number of fouls increase, so do the number of points. As for the strength, I would maybe put this as kind of a moderate to strong. And again, this is where it would be nice to have kind of an R value to help us out with that. But based on the data, I would say, at least for the first part of the data, kind of right in here, this area right here, I would say a strong relationship. But then I would say much more moderate to weak further on out as you increase. So that's why I would say moderate to strong. Probably end up being more moderate if we did have an R value for it, but we don't. For the form, it's kind of an interesting one. I would still maybe say linear, although I could almost see exponential. So linear, if you were to draw on a line of best fit, would kind of make sense there. But so would an exponential. So that one's kind of tough. I have a hard time deciding whether or not you could truly say linear or if exponential might actually be a better form for the data. The very last thing we need to talk about, remember when you're describing an association, is outliers or influential points. And really, to me, the only one I could maybe see is the point at 325 fouls as being an outlier or influential point. I would say everything else pretty much fits in with the rest of the data, and I think even it would be kind of a stretch to be called an outlier, because then you could also make the argument for these being influential points as well. So I have a hard time really saying for sure that that's an outlier. I would say it's definitely influential in the same way that the other points are as well. So for B, should NBA players commit more fouls if they want to score more points? And you know, at first, just a basic understanding, you'd maybe say yes, because obviously as your fouls increase, so do the points. But I would say no. And the reason for that, my explanation would be that there's a lot more variation for players with more fouls. which I think was something that I was kind of mentioning as we were talking about the strength of the relationship, is that, yeah, while there is going to be some of these players that have more fouls and have more points, you also have some players that have more fouls and have less points. So because of that kind of increase in the variation, that there's a lot more variability as you get further out, I would say that you probably don't want to take that route. So, all right, well, that wraps up Unit 11, guys. That is it for this year. I do have the Unit 11 test that I'm posting as a take-home test that is going to be on Schoology at 8 a.m. Friday. So again, I'll write this here in the notes for you to have. But Unit 11 take-home test will be assigned Friday at 8 a.m. It's going to be due on Monday by 11:59 p.m. Now, along with everything else at this point, remember, it's all kind of just, if you want to do it, do it. If you don't want to, I mean, if you're taking the AP test, you probably should be taking this just as a practice test. It's not going to hurt your grades, so why not give it a shot? I will probably take it down, though, after Monday night, just because I don't want the test kind of out and about. So I will probably take it down once the deadline is passed, and then I'll give you your feedback. Make sure that you take clear pictures of it, or make sure it's a clear scan if you're using a scanner, just so that I can read everything. If it's blurry, I might not be able to give you as good a feedback. So, all right. Well, that is it as far as notes videos go. Don't forget, I will still have my office hour daily from 10:30 to 11:30. So feel free to check in, ask questions, stop on by. As we get closer to AP test, I might open that office hour up to include some more hours, maybe in the evening or weekends. That way, for those that are really studying hard and getting ready for the AP exam, you can kind of have some extra time that's set aside just for AP test takers. So, all right. Well, we will have some more activities, and I'm sure I'll make some more videos for you. But this is the end of the notes. So have a great rest of your day.